Algebra 2 lesson 13.2. Describe the transformation from each parent function and give the domain and range of the function. All right, on number 1 here, if you notice, it has a +3 added to it. What that's going to be is a vertical transformation up 3 units. Okay, and then let's see what else. Domain, the domain is going to be x such that x is all real numbers. And the range is going to be y such that y, I'm looking here, a is 1, which is positive, so it's going to be greater than, and k is 3, so it's going to be greater than 3. All right, let's take a look at number 2. If you notice here, we've got h equals -4. We got h equals -4. That's going to be a horizontal translation and negatives to send it left 4 units. All right. Our domain is going to be x such that x is all real numbers, and our range is going to be y such that y is greater than, a is positive, so it's going to be greater than, and k is 0, so it's going to be greater than 0. All right, so starting to put some of this together here. Let's see, what do we, oh, I didn't mean to do that. We've got the equation is g of x equals a times b, and that's going to be x minus h and plus k. So a is going to be a vertical stretch or compression. And may reflect over the x-axis. B is our base, and then H is a horizontal translation, left to right. And K is a vertical translation up or down. These are your transform points, and the other one was h minus 1 and a over b plus k. You'll use this when b is between 0 and 1. All right, so let's try number 3. We got a is -1, so that's going to reflect over the x-axis. H is +1, and that's going to be a horizontal translation left 1 unit, and K equals 2. That's going to be a vertical translation up 2 units. So this reflect over x-axis, and this And this is going to be a vertical translation up 2 units. And domain is going to be x such that x is all real numbers. And the range is going to be y such that, all right, a is negative, so that's going to be y is less than, and k is 2. All right. Well, let's take a look at number 4. A is 3, and that's going to be vertical stretch by a factor of 3. And let's see here. H is negative 3. That's going to be a horizontal translation. Left 3 units. And see, K is negative 6, and that's going to be a vertical translation down 6 units. The domain is going to be all real numbers. Domain is going to be x such that x is all real numbers. And the range is going to be y such that y is positive, so it's going to be greater than negative 6. All right. Doing well. Let's try number 5. It says graph the given transform function. Then describe the domain and range of the transform function using set notation. Okay. Step 1, let's find out what A, B, H, and K are. A is negative 2, B is 1/2, H is 1, and K is 2. All right. Let's see. We're going to have to find the domain and range. So the domain is going to be x such that x is all real numbers. And our range is going to be y such that y is, oh, that's negative, so it's going to be less than, and k is 2. All right. Now, since k equals 2, that gives us our horizontal asymptote. And that's going to be right there. And let's see, we've got the two reference points I gave you a minute ago, H and A plus K. So H is 1, A is negative 2 plus 2, and that's going to give you 1, 0. So let's see, 1, 0 is right there. Our second reference point is H minus 1, and then A over B plus K. That's going to give us 1 minus 1, and then A, that's negative 2, divided by B, which is 1/2, and then plus 2. So what do we got here? 1 minus 1 is 0. Negative 2 divided by 1/2 is negative 4. Negative 4 plus 2 is negative 2. So we got 0, negative 2. And our graph is going to look something like this right here. All right, excellent job. Let's try number 6. Step 1, find A, B, H and K. Find your domain. Find your range. Positive, so it's going to be greater than, K is 3. That gives you your horizontal asymptote. Horizontal asymptote is y equals 3. We get that from our K. We have H, A plus K. And that's going to be, well, H is -2. A is 1 plus 3. And that's going to give you 4. So -2, 4, right there. Our second point, H minus 1, A over B plus K. And that's going to be, well, let's see here, -2 minus 1, and 1 over 1/4 plus 3. And let's see, -2, that's going to be -3, and that's going to be 4 plus 3 is 7. So -3 and 7 is maybe right there. And it looks something like this right here. I turned a little sharp there. Didn't mean to. All right. Number 7. What I want you to do is try this one on your own, okay? And try it on your own. And there's the answer to number 7. Number 8, I would like for you to try on your own. And show your work. Number 9, oh, this is a little bit different. Number 9, okay, we have the line, and we need to write the equation. All right, let's look at our domain. X such X is all real numbers, and our range is Y such that, Y such that Y is greater than -1. Okay, we're going to need A, B, H, and K. Now, since our horizontal asymptote is y equals -1, that means K is -1. And if you look at this point here, 4, 3, that's supposed to be H and A plus K. So that gives us H is 4, and then A plus K equals 3. Well, we know K is -1, so that's like A minus 1. Let's add 1 to both sides, and we get A equals 4. That just leaves B. Well, if you look at this point here, this is supposed to be H minus 1 and A over B plus K. So we got A over B plus K equals 7. Well, we know K is -1, so that's going to be -1. We know A is 4. Okay, so now let's solve for B. Add 1 to both sides, and you have 4 over B equals 8. Multiply both sides by B, and you get 4 equals 8B. Divide both sides by 8, and you get 1/2 equals B. All right, good. Now we can write our equation. It's going to be G of X equals, A is 4. That's going to be 1/2. And then we have X minus 4 and -1. All right, good job. Number 10. All right, so what do we got? Our domain is all real numbers. Our range is y such that y, it's less than 3. Okay, so that tells us a couple things. One, it tells us that A is negative, and two, it tells us that K equals 3. So we got A equals, B equals, H equals, and K equals. Well, let's see, K is 3, all right. And then, let's see, H, A plus K, and in this case that is -4 and 1. So H equals -4, and A plus K equals 1. Well, K is 3. So if we subtract 3 from both sides, we get A equals -2. So now all we're lacking is B. And let's see, right here, that's going to give us B. A over B plus K equals -3. Well, we know K is 3. We know A is -2. Subtract 3 from both sides, and that gives us -6. And then -2 equals -6B. So 1/3 equals B. That's going to give us an equation of G of X equals -2 times 1/3 to the X plus 4, that's plus 4, and then plus 3. And there's our equation. Number 11. Okay, what I'd like for you to do is stop the video and try to determine what A is and what B is. H in this case is going to be 0, and K is going to be 0. All right, stop the video and see if you can come up with what those are. I got 10 for A, and I got 1 minus 0.05, which equals 0.95 for B. So let's see here. What does that do? F of X equals 10 times 0.95, and that's to the X power. And the other one, it says half. So I'm going to say F of X equals 5. Now, I'm using X because the calculator doesn't take anything else. You could use T, all right? So if we go to our calculator, we have 10 times, open parentheses, 0.95, close parentheses, caret X. That gives us our first one, tab. We'll put 5 in there. That gives us our second one. Now we need to find out where these two lines cross. Menu, 6, 4, and they cross at 13.5. So X equals 13.5. And basically what that says is it takes 13.5 minutes for the insulin to go from 10 units to 5 units. Let's try number 12. Carbon-14 is a radioactive isotope of carbon that is used to date fossils. There are about 1.5 atoms of carbon-14 for every trillion atoms of carbon in the atmosphere, which is known as 1.5 parts per trillion. Carbon is a living organism, has the same concentration as carbon-14. When an organism dies, the carbon-14 content decays at a rate of 11.4% per millennium, or every 1,000 years. Write the equation for carbon-14 concentration in parts per trillion as a function of time in millennium, and determine how old a fossil must be that has a measured concentration of 0.2 parts per trillion. So we need to figure out a couple things. We need to figure out what A is. And I'm getting 1.5. B, that would be, well, let's see, 1 minus 0.114, and that gives me 0.886. So I'm going to have f of x equals 1.5 times 0.886x. All right. And let's see here. For my other line, I'm going to say f of x equals 0.2. Okay, because that's what I'm trying to find out, how long it takes it to go from 1.5 to 0.2. So let's go in here on new, no, and go to graphs, and we have, well, it's going to be 1.5 times 0.886 caret x. And then our second line is going to be 0.2. Let's move these two away. And it must be in there somewhere. So we got menu 6, 4. It pops up at 16.6. Good. So x equals 16.65, to be a bit more precise. So the fossil is about 16,650 years old, or 16.65 millennia. All right, there we go. Last one, number 13. String instruments like guitars and pianos create a note when a string vibrates back and forth. I want you to find out what A is, what B is. Write the equation, and then the other equation, and find X. All right, show your work. Thank you very much. You have a wonderful evening, and see you tomorrow.